Ladies and gentlemen, welcome to PASCO Laboratories. It's so nice to have you join us again for another session of PASCO Live. We are going to do all kinds of great things today, and we're really very excited about it because this week, of course, you know, I'm JP, and this week the P stands for programming. That's right, programming. Now, I know that's an old school term. Most of you are probably more familiar with the new term that we're using, coding. Now, coding is programming, but when you take coding and you start integrating it into our classrooms, it really shows up as a different term, computational thinking. Now, whether you're one of the 39 states with computer science standards or you're any of our states that's integrating computational thinking into our classroom, you know that this has become the new catchword. And I'm going to show you how we can integrate computational thinking to make your program STEM. Now, we've already been doing coding and programming for STEM, and you've been doing it for years, many of our teachers out there. And the way that we've been doing it has been with robotics. And you all recognize that STEM and robotics have always go hand in hand. And maybe not that type of robotics, but maybe more like this type of robotics. And this is the traditional way that we do robotics in our classroom. And of course, it's always been a question of, how do I get this to help me teach things like chemistry and biology? Well, it's tough. But then on the other hand, I've got this nice pH sensor, and this pH sensor is great for teaching all things biology and chemistry, but I can't code it. I can't make it do anything. So wouldn't it be great if I could take our robotics and coding and programming and our pH sensor and integrate the two together so that I could actually use coding to learn more about science? Wouldn't that be nice? Well, it's great. Actually, we did it. And I'm going to show you about it today live, right here on PASCO Live. Let me introduce you to our studio audience so you know who is here working with us today. On drums, our program director, Glenn Starkey. On camera, Nolan Gettler. Our program coordinator on the keyboard, Janet Gomez. On the guitar and in the chat room, Brett Sackett. And helping us answer questions today, because everything we're talking about is computer science and computational thinking, we brought in Hbrennan. She's a computational thinking expert. In fact, she brought computer science standards to the state of Florida. Now she's going to help bring computer science standards into what we do and help you at home as well. Now, everything that we're doing has this flair of if I'm at the lab or I'm in the class or I'm at home, and we're going to do that today also. In fact, I'm working here at PASCO Laboratory, but we're connected to our student at home. Let's check in with our student at home and see what he's up to, Hunter Jensen.
Coding during this live presentation. So please, I hope to show you more later.
Excellent. We'll be checking back with Hunter in a little bit, but if you were listening very closely to what Hunter just said, he said that I gave him a coding challenge that used a pH sensor. A coding challenge that used a pH sensor. Sound exciting? It is, and it's possible because we've integrated coding right into our software. Of course, you know our software works with any of our sensors with PASCO Scientific. Let me show you a little bit about what that looks like and what you'll see when you open up our software. I want to take you to what you will see and how things look in both SPARKvue and Capstone. This right here is an example of what a code would look like in our coding window. I want to go through the coding window a little bit and show you what you're going to find here. Within the window itself, you'll notice on the left-hand side, we've got some blocks that are available to do different types of coding. For logic, for example, are if-then statements that we're able to use. If we continue down, we're able to put in loops that allow me to do a process for a set number of times or to run this for infinity. And we're able to use loops to do a variety of things that we want to take place over a long period of time. Also on that list, you're going to notice that there is math, so that we can do mathematical calculations, input, output, numbers that we need to show up, all part of math. And if you look further down that screen without opening up all the little blocks, you'll see that we have texts, lists, variables, functions, hardware, code output, and time. And of course, these are all terms that we use in computer science. And here's the neat thing. This is the code that's within the software, but the code in the software allows us to collect data and then to display that data and some type of output. As we can see here in this window, I've written a program to keep a drink at a constant temperature, when to add ice, when not to add ice. You can see the program is running, the temperature is indicated, and great work because this is the temperature that I said was a perfect temperature for that drink and how that program works to maintain that. So this just gives you a feeling for what you can do. And I'm going to give you even better feeling because I'm going to do some with you right now. In fact, I'm writing a program currently to identify a base. Now I'm using my pH sensor again, so I'm trying to identify a base. I've got my pH sensor. Let me go to my software, and I'm going to build this code for you right here. So here's my SPARKvue window. You can see the different items that I'm working with, and you'll notice right away I have a sleep function at the very top. And I put that sleep function in there because you're probably aware that it takes a little bit of time for my sensor, which is Bluetooth, to connect to my computer. And that little transition time is why I'm building in a sleep function. So I give it a moment for this to connect to this, these two items to connect, and when they connect, I'm able to start collecting data. So I have that sleep function. And I'm going to repeat this measurement while true, which is going to be an infinity statement. This is going to continue to run as long as the basis for my program remains true. So I have an if, do, else statement, and I'm going to drag that right in here. And so what I've said is, if the pH is greater than or equal to 7.1, then my text output is going to say base. That's what the program says so far. And I also want, in my else, if the text output otherwise, if it's not a base, what is it? Well, for today, I'm just going to put in the question mark, because I'm only writing the program to say it's a base. Take a look at my program. Of course, if you have any suggestions, you know this is only one way to do it, and Hbrennan is standing by in the chat. If you have questions about how can I do that, how can I write that, can you change this, Heidi's standing by for your questions. And of course, ladies and gentlemen, anytime you have questions, just send them in. Janet will just step over and say we've got questions. Brett will step over and say we have questions. But what I really want to do is show you how this program runs. So I'm done. I wrote my program, and you'll notice now that I have my pH sensor. It's in a basic solution, and you'll notice that my output says base, so that my program is running. Now, what if I were to put this in an acid? Well, I have an acid sample here. Let's watch what happens when I transfer my pH sensor from the base to an acid. Let's watch our display. And what does the display do? It puts the question mark, because I never asked it to identify the acid. And so far, what I've done, if I'm in my classroom, I've taught a little bit about coding because I've introduced the loop and I've introduced the conditional logic. So I've introduced some coding. Now I'm using coding to learn. And what am I learning about? pH. I've identified an acid, or rather I've identified a base, and I'm going to ask my students, can you now write a program that's going to identify acids and bases and neutral solutions? What would you have to do? Think back to my initial program. Here's my initial program. What do you have to do to make this identify acids, bases, and neutral solutions? If you've got a great idea, send it over to Heidi. Let her take a look at it, and let's see. I'll give you a second to put your ideas in, and then I'll show you my idea. Okay. Hopefully you have some ideas on how you're going to do that. Now remember, ladies and gentlemen, there are probably 1,000 ways to write a computer program. I'm going to show you one way that I did it, and you might look at it and say, I see a flaw. And actually, I can see the flaw too. If you catch it, send it in to Heidi and let her know that you're actually paying attention. But take a look at the program that I wrote. I have the sleep function, which is allowing me to connect to my sensor. I haven't integrated a second sleep function in there because every time I run this loop, I want my pH sensor to get back to 0 so that I can keep recording. So I've integrated in yet a second sleep function. And so take a look at my if do, else if do statement. If my pH is equal to 7, it's going to tell me neutral. If it's greater than or equal to 7.1, it's going to tell me base. And if it is anything else, it's going to say acid. Now, if you're clever, you're going to see a flaw in that program. This isn't bad. This will actually work pretty nicely. But there is a flaw. See if you can find it and send it over to Heidi. Now, again, I'm in the classroom. I've just taught about pH. I've been talking about pH and acids and bases, and I've been doing acid and base demonstrations, and I've been using the pH sensor. Now my kids in a hybrid situation are working from home, and I'm sending a pH sensor home with my kids so that they can actually do some testing at home using some household items and the coding and the stuff that we're learning. I'm going to send them home with this challenge, and this is the challenge that I gave to Hunter right before we started this program. And I said, Hunter, select 3 substances from home and design a program to identify each of them using only the pH sensor. Well, let's see how Hunter did. Let's check in with Hunter at home.
So according to Dr. Keener's challenge, I have obtained 3 different substances from which I can determine their pHs from. Now, in order to correctly identify them using pH, we have to establish what their pHs actually are. So in testing, the water came out as a 6.7 pH, the tea came out at 2.87 pH, and the soda came out at 2.15 pH. Now, using these pH measurements, I can establish a range from which I can use on conditional statements to actually determine which substance it is. So, on the program that I've been working with, I have my sleep functions to establish connection before we get into the loop. Now, this loop will repeat forever because it repeats while it's true, and that sleep one on the inside allows for it to zero out through every single measurement. Then, in the conditional statements, we have the separate ranges from which each substance appears in. So for the value of pH that is greater than 1 but less than 2.5, it'll register as soda acidic. From the value of pH greater than 2.5 but less than 3.5, it'll register as tea acidic. And for the value of pH greater than 5 but less than 7, it'll register as water acidic. And anything else outside of those ranges will register as an unknown to the program. Now, to actually put this into practice, I will test with my pH sensor. So, starting the program, I dip it into the soda, and it correctly identifies it as soda acidic. I now rinse off in a separate water container so that we get proper measurements. Put it in the tea, and we get tea acidic. Then for the final measurement of the water, rinsing once before, we obtain water acidic. Now, doing this process, I can make a short video of this and submit it to Dr. Keener in order for him to review it. And now, I've also learned how to measure pH substances from things around my house. And I can use that to be a little bit more fun with it, going around measuring different substances and their pH.
Excellent. Thank you, Hunter. And Hunter did that. He emailed me his program, which I'm taking a look at here on my screen. He has sent this over to me, and I'm taking a look at the program. I'm seeing how it's written. I'm taking a look at his video. I see exactly what he did and how he tested it, and I'm very proud of the work that he did. And if you're working with me and you're taking a look at this, and you were watching Hunter, you saw that Hunter he's easily identifying acids and bases. He's showing correct laboratory procedures. He's testing things at home right out of the household refrigerator. He's doing real science and he's doing real coding to learn that science. And that's our mantra. I've shown him a lot about the coding, so he learned to code. And then I showed him a whole bunch about pH, so we used that code to learn. And that's what we say here. Learn to code, code to learn. Now, when Hunter comes back, I'm going to give them yet another challenge with pH. When they come back to the classroom, we're going to put them in proper gear with the proper safety precautions, and I'm going to have them do 3 different titrations with 3 different acids. And I'm going to have them collect that data. And I have the data here that was collected. Here you can see that I was using acetic acid, phosphoric acid, hydrochloric acid, and we did 3 different titrations. And look at this data. Now that I've done this little bit with the data, the question is, can you design a program to identify the 3 different acids? Now, Hunter already wrote a program to identify 3 things at home, and he did it by pH. And we can still do pH here. And take a look at this. Do you have some ideas on how you might be able to write a program to identify correctly these 3 different acids from what you see here? If you've got some ideas, send them in to Heidi, because she's looking for ways that we can actually put this together. And if you have some good ideas, we'll present it in a future program. In fact, actually, if you write it and send a picture, we'll get your picture, we'll get your program, and we'll put you up on the big screen so folks can be proud of you, of the work that you're doing. If I were looking at this, I know I'm going to use pH. I might maybe consider using slope. I may try to identify ranges. There's a lot of different things we could do here. But think about the learning. Acids, bases, titrations, polyprotic acids with the different bumps there and the way to identify them. Exciting stuff that I can use coding to learn. Now, you might be saying right away, like, hey, JP, I don't have a pH sensor, but I do have my phone, and my phone has a sound sensor. Can I use it? You most certainly can. In fact, that's exactly what our friends out in the United Arab Emirates at AtLab did. And we have a very exciting Miss Karpaga who did this at home using her phone, using the free software that you can download today. She is quarantined with her family and had to decide how to write a program to identify the different members of her family. And what did she use? Her sound sensor. And when she used her sound sensor, she was able to collect some data that identified the different members of her family by their decibel level. So here you can see that the daddy has his decibel peak, and she identifies that. And then she ran through every member of her family. And you can see here that everybody, it worked out very nicely, everybody's got a different sound level, so a different peak. And then she took that data and she integrated that into the code. And look how beautiful this is. Karpaga, you did such beautiful work with this that we are so excited to have it and to show it. Oh, and by the way, she's in the chat. So if you think she did a nice job, write her and say thank you for sharing this. And hopefully you'll all share something. But Karpaga, thank you for sharing this, because look at her code. She did some very nice ranges for the sound level. Those ranges help to identify each one. And then look how cute. The test, she ran it, and it was able to identify the small brother as correctly just based on his decibel level. So very nicely done, Karpaga. Thank you for AtLab and the United Arab Emirates for thinking about that and submitting that. And we were very happy to get it. And we're always happy to get your ideas. In fact, I'm not the only one who's happy. Hbrennan, our computational thinking expert, is always happy to get your ideas. If you do a code, you use your phone, you do a code, you take some pictures and send them in, we'd love to showcase them in future shows. Now, I still know what you're thinking. I'm pretty good at that. You're saying, I don't have any of those new sensors, but I do have these older sensors. Now what do I do? And the really great thing is, whether you're wired or wireless, the sensors all work the same. And so if you think it, you can do it. In fact, think about all the great things you can do. We talked about pH, but do you think you could write a program to identify winds for hurricane season? Our friends in Florida probably can. June 1st is our start date, by the way. Or how about identifying our different sports drinks by conductivity? Our wireless conductivity sensor would be great. And think about the things you could teach about the different types of electrolytes dissolved in our sports drinks. Or photosynthesis and our carbon dioxide sensor? You bet. Or those of you that have our smart cart, think about all the great things you can do with a force sensor or our acceleration and velocity that can be recorded by this device. Think about the programs that you can write. And there is so much more. If you can dream it, you can build it. Now, still, you don't have any of this, and you're saying, how do I get some of these sensors? We've thought about you. In fact, we've put together entire kits that are ready for you to use today. And each one of these kits, in this case, I have the chemistry kit, the chemistry lab station that's prepared for you. Each chemistry lab station, biology lab station, physics lab station, middle school, elementary school, even ag science comes with a manual that's already been prepared. And within the manual, you're going to find activities. And take a look at the neat thing with these activities, examples of extensions that can be used for coding. So we've got it all figured out for you. Whether you have old equipment, no equipment, new equipment, or you need equipment, we have ideas for you. And if you stay tuned for just a couple minutes, there's even a special deal. I'm going to show you how to get some of this stuff at the end of the show. But let me add a moment of relevance. how about we think a little bit about what we're all talking about now, temperature. Now, this is my temperature sensor, and I know everybody's talking about now recording your temperature before you go to work. So wouldn't it be great if I could write a program that allowed me to identify if somebody has a fever before they come to class? Well, I bet you we can, and I bet you Hunter could do it best. So I gave the challenge to our student at home. Let's check in with Hunter at home and see how he's doing with my second coding challenge. Can you write a program to tell me if you have a fever?
So before I used the temperature sensor to record my own temperature, I did a little bit of research. According to the CDC, any temperature below 100.3 is a healthy temperature for a human to have. However, if you have over an 100.3 degrees Fahrenheit temperature, then that means you have a fever. So using this, I can create ranges in order to determine if I have a fever or not. So this is not a medical device. I cannot put this in my mouth, nor can I use this on my forehead to get an accurate reading. Therefore, I must use the next best option, which is to put it under my arm, which registers about 1 degree less than if I were to do it on my forehead. So using that, I must modify my numbers in my coding in order to balance it out appropriately. As for the program, we begin with a sleep function in order to actually get it connected before we do any measurements. Then we have a repeat while true to ensure that it will repeat forever as long as I do my measurements. Then, as for the ranges in the conditional statements, if the temperature reading on this temperature sensor is greater than 99.3, it'll register as a fever and tell me so. However, if it's under 99.3 degrees Fahrenheit, then it'll register as no fever and I will be deemed safe. So, in order to do it on myself, we will start the program, and I have it underneath my arm, and I'll hand it back to Dr. Keener because it will take a while for it to equal out.
Excellent. So Hunter's at home. He's measuring his temperature. We'll check back to make sure he's safe before he comes to class, writing a program that he wrote. Think about all the things he just learned. He went to the CDC website. He did research. He learned about temperatures. He learned about different places around our body that have different temperatures, where to measure. And of course, I know we're all happy he selected under his arm. But there are also things that we can think about. Take a look at my students here. And they're working, and they're doing a lab specifically on just taking a look at phase changes and writing a program to see if they can identify when we go through a phase change from solid to liquid to gas, and they're writing that program and they're learning about all the science. And that's the exciting thing here. We're not just learning about science, we're using coding to learn about science, and we're even learning about the coding in the process. Now, one of the things that you are probably saying is, hey JP, that's great, but when I do robotics does bells and whistles and lights that flash, and that's really fun. But the thing you're showing me is only giving me text output. And so far, that's what I've shown you, and that's true. And you're thinking, wouldn't it be great if I could integrate those two together so that I actually could have lights and bells and whistles and noises? Well, we can. In fact, we did, and we're doing it live next week with Hbrennan. She's going to introduce to you our brand new device called the Code Node. And the Code Node is a device that has both input and output and lights and noises and arrays that we can program with any of our sensors or even the sensors that it has. So next week, computational thinking with expert Hbrennan and the Code Node that takes us even a step further on what we can do here. And if you're thinking, well, I would like to look at these activities and get a feel for how they might work in my classroom, you can. Just go to pasco.com and take a look in our experiment library. If you type in the search, if you type in Blockly, you're going to see a growing list of labs that are being written, the extensions that are written around Blockly. And if you continue to look, you're going to find more extensions that come every single day. Now, let's check back with Hunter and see how his temperature is. Thumbs up or thumbs down, Hunter? Excellent. No fever. Hunter can come back to class, and he did that with a program he wrote with a PASCO scientific sensor and the coding that we learned today with the simple things that we did. So how excited are you? You should be very excited. If we have questions coming in, I know they're being answered. Continue those questions coming in. And now I want to offer you that special deal. Remember I told you that we have kits prepared for you? Well, we do, and we're ready to get those to you. And so think about, I've got kits, I want to do this hybrid kind of learning, I want to be able to teach coding at home, I want to be able to do things in my classroom, and when my kids come back, I want that equipment. Great. Standing by our own Isaac Martin is ready to talk to you about special deals that he can offer you here within the United States when you start purchasing these things today for your school, for your district, to get you on track for teaching in class, at school, at home, in a hybrid solution. And so maybe you're watching us from a distance. That's okay too. We have over 100 partners around the United States, and we would love for them to connect, just like Ms. Karpaga and AtLab. We have 100 others, and you can find your local rep right there on our PASCO website, right here on a URL that's being provided for you. And so, ladies and gentlemen, I want to thank you for joining me today. I hope you saw a little bit about how computational thinking can be brought into your classroom. I hope you understand that it's not just about robotics anymore. It's about teaching, and it's about learning to code, and it's about using coding to learn. From all of us here at PASCO Laboratories, we're wishing you the best of luck, great teaching, and good day.